Okay, now if you will see for the third case, that is for a particular frequency of this AC source, say the omega AC is equal to omega naught, what we will find out that this XL and XC becomes same. That is, we know that as we increase the frequency of AC source, say my left hand is XL, my right hand is XC. So as I will increase the frequency, XL will increase and XC will decrease, and then we will find out that at a particular frequency these two will become same there. So XL becomes equal to XC. In that case, if you will find out the total impedance of the circuit that is being offered by these three elements, then that will come out to be simply equal to R. Why? Because we have the expression for Z is simply Z will be equal to under root of XL minus XC whole square plus R. Whether you write it XC minus XL or XL minus XC, because squaring of that will give you positive only there. Okay, so if XL and XC becomes equal, then in that case that term will be 0 and Z will be minimum in that case, because this Z is the this Z term is basically the sum of two positive terms there. This is also a positive one, square of that, and this is also a positive term. So one of the term becomes 0, and in that case Z will have minimum value, what? Simply equal to R. And then because of that Z minimum, the current supplied by this particular AC source of certain frequency, that is equal to omega naught, that will be maximum. So if you will find out the peak value of the AC current, that will be maximum as compared to the current given by any other frequency source there. This will remain same, but I am changing the frequency of the AC source. So for this particular frequency of AC source, the current supplied by the source will be maximum as compared to any other frequency, and that will be simply given by V naught by Z minimum, that is V naught by R. So this is the maximum current which is being supplied by this particular AC source, whose frequency is something equal to omega naught, where XL becomes equal to XC. This is called this condition is called the resonance condition there. And you know very well that we can find out this particular value of this frequency of AC source where XL becomes equal to XC very easily. What is XL? That becomes omega naught L. Where is XC? That becomes 1 by omega naught C. So from here omega naught is 1 by root LC. This earlier we have done it in the LC circuit, and this is called the natural frequency of the LC circuit. We will see it that what this correspond to for a LC circuit, wherever we have L and C, what this correspond to. So if we simply say that if the frequency of AC source is equal to, say, the natural frequency of the LC circuit, L and C being used in the circuit, that is 1 by root LC, then XL and XC becomes equal and the impedance will be minimum and the current will be maximum because of that particular source. Is it clear? So this is being said resonance condition. In either way, we say that at this particular frequency these two will match, or we say that if the frequency of AC source matches the natural frequency of the LC circuit, then we say that because of that source the current will be maximum. So in this case, resonance condition, the circuit is completely resistive in nature, because VL and VC will be equal. If XL and XC will be equal, they will cancel out. So what is only left out? This is I, and this applied voltage will be simply equal to VR. The applied voltage will be simply equal to VR. The V is the resultant of these three, VL, VC, VR. VL and VC will get cancelled out because XL and XC are equal. So in this case of resonance, the circuit is completely resistive and the voltage and current are in the same phase there. If we draw the graph for this particular circuit, graph between the impedance and the frequency of the AC source, impedance and the frequency of the AC source, that's the impedance and the frequency of AC source. Say this is the resonant frequency, I will call it resonant frequency. Okay, then we know that as we increase the frequency, the Z will decrease, and as Z will decrease, and at this the resonant frequency, the Z is minimum, that is equal to R. So that's the graph between Z versus the impedance versus the frequency of the AC source Similarly, we can draw the graph between the I, the current flowing, that is I'm only drawing the peak value of the AC current, okay, versus the frequency of AC source, that's the resonant frequency. Okay, then simply the graph will be something like this, they are not identical, there. So at when the frequency of AC source is equal to the omega naught, that is the natural frequency, then the current will be maximum, that is simply V naught by R there. Okay, so this is LCR circuit, and practically we won't get an LC circuit, in practical. We'll always get a LCR. Why? Because the inductor is made up of the wire which have some resistance also.